Here we are, video again. I show everything in pen so you guys can see it on the screen, but you should be using pencil when you're doing your practice, because when you do your practice, you're going to make lots of mistakes. Notes in pen is fine. Here we go. We're going to do a system of linear equations. That's when we have two linear equations, and you can solve it graphing, substitution, elimination. That's what I'm going to do an example of. But I just want to review that there's three different possible answers. So if your two lines intersect, then there is one solution. S-O-L-U. Okay, one solution, and you're going to get x equals a number and y equals a number, so then the ordered pair is your solution. But sometimes, I don't think this will happen in our practice, because I want you to get an answer. Sometimes two lines never intersect, they're parallel, and that means there is no solution. So the solution to a system is the point where they intersect. It's this point. But if two lines never intersect, then there's no solution. What would that look like in your math? In your math, it would look like this. You would get x equals x, or maybe 0 equals 0. And these are true statements. Oh, Katie, I am doing this wrong. Hi, let's go back. Let's erase. It takes a lot to rewind the video and restart it. So I apologize. I was doing the opposite. So a no solution means you get something like maybe I will go back because this is wasting time. 5 equals 0. Hi friends, does 5 equal 0? No, that is a false statement. False statement. Okay? If you get a false statement, then it's no solution and the lines would never intersect. What if you have the line on top of a line? Whoa, and it ends up being the same line. Well, if they're on top of each other, how many points do they intersect? They intersect infinitely many times. Infinite. So there are infinite solutions. And what would that look like on your paper? That would be if you got a true statement. Like all the x's and y's go away and you get a true statement. All right, sorry for that mistake, but guess what? I make mistakes. Do I make a lot of mistakes in life? Yes. In math? Not really. Here we go. I'm going to do one, and then you're going to do 3 more. So we're getting shorter, guys. We're halfway done. This is 3 out of 4. You ready? Solve the system by graphing. Step 1, solve each equation for y. This means write the equation in slope-intercept form, which we've practiced. So you should have completed packet 2 before coming to number 3, because we need to practice this. How do we move the x's? By subtraction. Now we like to have the x's in front, so it's going to be a negative 3x plus 45. And we need to get the y by itself. So we're going to divide by negative 5. And when you divide, make sure you divide everything. I don't do one big line, I do division by each term. It makes more sense to me. A negative divided by a negative is a positive, and positive 45 divided by negative 5, negative 9. Is that right? Okay, equation 1 is done. Now we need to do the second equation. 11x plus 5y equals 25. Move the 11x's to the other side by subtraction. 5y equals negative 11x plus 25. And what else do we have to do? We got to get the y by itself. So we're going to divide by 5. That's kind of a silly slope, huh? Negative 11 over 5. Here we go. I really don't like you guys to write your fractions like this, because later on in the year you really get I see students get really confused as to what's the numerator and what's denominator, and rise over run. When it's like you need to know that negative 11 is the numerator and 5 is the denominator. So please don't write your fractions like this. Write them on top and bottom if you have room. There go my lights. So we have color changes. Okay, we got a graph next. Step 2, graph both lines perfectly. What? Perfectly? Okay. Where are my lines? I got lost. They got lost in the math. Here we go. There's one. And there's the other one. So this one has a y-intercept of -9. And is this slope positive or negative? It's positive because we had a negative divided by negative. Okay, check. So we're going to go up 3, 1, 2, 3 over 5. 1, 2, 3, 4, 5. Do it again. Up 3 over 5. 1, 2, 3, 4, 5. Can it fit going this way? Nope. But graph more slopes if you can. Is that perfect? I hope so, unless I made some major mistake. Looks good to me. All right, let's graph this line. What's the y-intercept? Y-intercept is +5. Begin here. It's a B. Begin here. Move this way. It's a negative slope, so we're going to go down 11 to the right 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then over 5. 1, 2, 3, 4, 5. Look at that. We're right here. That's good news. I can't really fit another slope, can I? And do you have an ID card or a credit card? If you have a credit card, can I have some money? Just kidding. There we go. Graph both lines. Identify the intersection point. Where did they intersect? Solution. What is our solution? We write it as an ordered pair. So the x value is 5 and the y value is -6. Done. No, not done. Question 3 says, now solve the system using the elimination method. Make sure to solve for both x and y and write as an ordered pair. Here we go. So we're going to line them up again. And we're going to eliminate one of the letters. So what do you want to eliminate, the x's or the y's? What would be easiest? Don't the y's eliminate right now because we have opposites? Ooh, see how I'm using my word? Not my word, but just the math word of the whole universe. -5 and +5 are opposites, so they add to 0. So we're just going to add down. We don't have to multiply by anything. 11 plus 3 is 14. So we have 14x equals 5 plus 5 is 10. Carry the 1. 6, 7. 14x equals 70. And divide by 14. No one will know if you're using a calculator, if you want to use one. Do you know what? Without a calculator, I know that 7 goes into both of these, so let's divide by 7, and I get 10 over 2. What do you know? What's 10 divided by 2? 10 divided by 2 is 5. I'm going to circle it because I know it's one of the answers. How do we find the second answer? How do we find the y? Do you remember how to do that? We're going to take the 5 and we're going to plug it in, and this is where students go, but which equation do we plug it in for? And the teacher goes, it doesn't matter. So I'm just going to use the top one. Usually teachers use the first one. And make sure you put, if you solved for x, make sure you plug it into x. And now we're going to find y. 3 times 5 is 15 equals -5y equals 45. And subtract 15. I'm still here. Are you here? Just doing math, peace and quiet. I'm out of the screen. Oh no, there we go. Okay, y equals, we have a positive divided by a negative, positive 30 divided by -5 equals -6. Awesome. Did we solve for x and y? Yep. Do our answers match the graph? What? Cool, huh? So we're just solving the equations different ways. We used elimination, we used graphing. Oh, we're not doing substitution on this one, but we'll review that, I guess, during the school year. Show, what are we doing now? Show that the ordered pair you found in 1 and 3 is indeed the solution to the originals. Look at that, a typo! How silly. The original system of linear equations. I wonder if that's on every packet in the whole world. On every page. Oh my goodness. How silly, Mrs. Keener. Should I throw them away and reprint? Nope. Here we go. Oh well, sorry about that. How do we show that an answer is a solution to a system? You have to plug them in and it has to be true for both. So you can't just plug into one, you got to plug them into both. So here we go. 3x minus 5y equals 45. And we're going to show that that's a true statement. I don't know, like in 2 steps. And then we're going to plug it into the second equation. 11x plus 5y equals 25. And then we'll show that that is a true equation. You ready? Get set. What is our x value? X is first, so x is 5, and the y value is negative 6. 3 times 5 is 15, and negative 5 times negative 6 is positive 30. And does 15 plus 30 equal 45? And that's a check. We're going to do it for the second equation. 11 times 5 is 55. 5 times negative 6. And does 55 minus 30 equal 25? Yes, it does. So, a little bit shorter, yay. I did number 1, and you're going to do the other 3. And for this one, we're going to use elimination, but the y's won't cancel the way they're written right now, because negative 2 and negative 2 is negative 4. Those aren't opposites. So do you remember what you have to do? You have to take 1 and multiply it by a negative. Oh, my lights just magically went on, which is a little scary, like there's a ghost in here maybe, because I'm here all by myself. Do you see how we distributed that? Here, here, and here? Then then we're done with this equation, and we use these 2 equations to eliminate. I was trying to let you go early before 15, but I want to make sure. Okay, will these eliminate? Yes. And then that typo, original. Who doesn't know how to spell original? And then those will eliminate too. So kind of like an easy elimination. You have all the answers, but you don't really need them on this one because your graph finds the answer and then you're just checking them here and here. Well, thank you for watching, and go ahead and finish packet 3. If you need any help, you can email me and I can send a picture or make more videos.